Okay, Foundations in Pre-Cal 10, Video 8. This is a bonus video for Arithmetic Sequence and Series. We are not covering it this quarter, but we may cover it in the semesters to come, so might as well throw it up here. Here we go. So sequence and series is all about numerical sequences. Now you can see on the bottom here that we have a sequence 1, 3, 9, 13, and then numbers fill in between and we finish with 23. This is just a generic sequence. There's nothing fancy that we can tie to it. We will in a minute, but the idea is here just get a bit of vocabulary. The 1 in this case is our first term, so we call it T1, term 1, or in some instances we'll just use the letter A. Those two are synonymous. The second term is T2. So you can see the subscript is the position in the list. The nth term, so in this case 23 would be the nth term because we don't know how many terms are in the list, so we call it the nth term. We can solve for the numbers in the list, but we just go from there. So kicking a sequence into an arithmetic sequence, though, is when we end up with a pattern. So you can see this sequence here, you might notice a pattern. You have 1, 5, 9, 13. So look at what we're looking for is a common difference, which means what is the difference between the terms? And we get that using subtraction. 5 minus 1 is 4. 9 minus 5 is 4. 13 minus 9 is 4. So we subtract the second term from the first, the third from the second, the fourth from the third, so on and so forth, and we get what is called a common difference. Now, if you look here, this is how we're going to generate our equation for an arithmetic sequence. The second term is the first term plus one difference. The third term is the second term plus a difference, but the second term is just the first term plus a difference. So we end up with the first term plus 2 times the difference. Now the thing you'll notice here is this is the third term and it's 2 times the difference. So we've taken the term number n and we've subtracted it by 1. So that continuation, that process is how we come up with this equation. Okay, the nth term is equal to the first term plus the common difference times whatever term down the list we're in minus 1. So this is a plug and play scenario. Okay, so you can see here we have an example where we have -3, 5, 13. So we could look for a few things here. We could look at the fact that, okay, my A or my T1 is -3, and my difference is, well, 5 minus -3 is 8. 13 minus 5 is 8. Well, my common difference then is 8. From there, you have information for pertinent chunks of this equation. We have this value here, and we have this value here, so we can now solve for any n value we want. And we're going to look at that here in the next slide. So, first, getting used to identifying the common difference. D is equal to T2 minus T1, which is equal to T3 minus T2, right? We subtract the previous term by the current term. So 2 from 1, 3 from 2, 2 from 3, so on and so forth. So in this case, we can say, okay, well, 5 minus 3 is equal to 2. But that's not enough. You need to check at least one more to make sure that that sequence stays true. Otherwise, you just have a list of numbers. And if you look at all of the comparisons in this case, I do in fact have a common difference of 2. Now it's possible that your common difference isn't a positive number because in this case we go, okay, 8 minus 11, -3, and we have 5 minus 8, -3. So we have a common difference in this case of a negative value, which is more than allowed. So now how about finding specific terms? So now we're at that point where here's our list, and we want to know the 12th terms. That means we want to know T12. Now that's important because remember, this is my n value, right? Tn, but in this case, my n is a 12. So I'm using my equation. Tn equals A or T1, I'll use T1 in this case, and then n minus 1 times D. And what we do is we plug and play. We plug in the information we have, we solve for what we need. So in this case, we know n is equal to 12. We can look and find that D is equal to 3. And we know that T1 is equal to 2. So what we're doing is we're going, okay, well, the 12th term is equal to the first term plus 12 minus 1 times my common difference of 3. And we just continue. 2 plus 11 times 3, 2 plus 33. So the 12th term in that list will be 35. So once we have the information, we then plug through to figure out what it is we need. So now in this next example, you see which term is 439, which means we're going to get yada, yada, yada over to 439. We want to know, well, what term is that? So in this case, we don't know n. Okay, we know that Tn is equal to 439. It's the nth term in my list, but I just don't know what n is. But we can keep the fact that that is Tn, because then we know that D in this case is 3, and T1 or A is equal to 4. So what we have now is we have Tn equals A plus n minus 1 times D, and we're going to fill in. This time though we have 439 is equal to 4 plus n minus 1 times 3. You see we're missing the n. Now we do a little bit of algebra here. Subtract 4 from both sides. 435 is equal to, I'll just rearrange these, easier to read, 3 times n minus 1. So let's keep the algebra going. We're going to divide both sides by 3, and that's going to give us n minus 1, right? We divide by 3, divide by 3. So now we get 435 divided by 3, we get 145 equals n minus 1. And if we add 1 to both sides, we get our n value. We get n equals 146. So it means 439 is the 146th term. So we would have T of 146 equals 439. We knew it was the nth term. We just didn't know what n was. So that is how you can find n. That can be a confusing aspect of arithmetic sequence and series, but that is the breakdown. Identify what's missing and find it. So these are some more complex scenarios now. If they give you a bit of information, so they tell you the 7th term is 78 and the 18th term is 45. Well, that means we have T7 equals 78 and we have T18 equals 45. So what we can get out of this is, in order to find the first term, we need D. We need to know what our common difference is. So if you look at the amount of terms, you have 18 terms and then 7 terms. So how many terms are in between? You have 11 terms in between. So what that means is you have 11 times your difference to give you the difference between those two terms. And what's the difference between term 45 and term 78? And you'll see I subtracted 78 from 45 because 45 is further down the sequence, and you get negative 33. So it means that 11 times the difference has to equate to negative 33. A little bit of algebra, divide by 11, divide by 11, D equals negative 3. So once we have the difference, we can then plug it back into our Tn equation for either of the 2 points we have. You can pick either one because we can plug in info. I'm going to use T7 in this instance. So I know that T7 is 78. We don't know A, that's what we're trying to solve for. I know that N is then 7, and I just solved for my D of negative 3. So then we just do a bit of computation followed by algebra. We get 6 times negative 3. I'm getting ahead of myself. 6 times negative 3. So we get 78 equals A plus negative 18, which is the same as minus 18. So then we add 18 to both sides, and we get our first term. So 78 plus 18 is 96. So that is term 1, or A. You could have used T18 of 45. The difference would have been this value, our Tn, we put in as 45, and our n value we put in as 18. You'll end up in the same place, but you can use either one. So what about the most complex? Well, here's a scenario where they give you 3 consecutive terms in a sequence, but they all have x's in them. So it means we have a sequence that looks 3x plus 2 as a term, and then 2x minus 3 as a term, and then 2 minus 4x as a term. So on its face, this gives us very little to work with. But what it does give us is it gives us a manner of determining our difference. And our difference is this term minus this term, or this term minus this term. And it's important here to keep your brackets so you do the subtraction correctly. We'll do the first. T2 minus T1 gives us 2x minus 3 minus 3x plus 2. That's going to give us D. Okay, and what we get is we get 2x minus 3 minus 3x minus 2. You got to water bomb in that negative. And we get that D is equal to negative x minus 5. Now, that doesn't really help us, but we got to keep looking at something else, okay? We got to look at the difference in green. So if we have 2 minus 4x minus 2x minus 3, that also equals D. And now we have 2 minus 4x minus 2x, again, water bomb in the negative, plus 3 equals D. So group this together and you get negative 6x plus 5 equals D. So what does that mean? Well, that means we have two different equations, both equal to D, which means we can set them equal to each other because D equals D. There should be no debate about that. They're the same. So we can just sub in their values and set them equal to each other. So now we have negative x minus 5, that's the first one, is equal to negative 6x plus 5. And what this does is this allows us to solve for x. This is what we want to do. So group our like terms. Add 6x to both sides, and then I'm going to add 5 to both sides. And that gets my x's on one side, 5x, equals my non-x's on the other, 10, and then divide by 5. Divide by 5, x equals 2. I'm going to think you're going to need to watch that example more than once, but that's why it's there. First, we solve for an aspect of D by getting them equal to each other, and then we can set two equations equal to one another and solve for our unknown information. Very handy tool, and you will use it again in the years to come. So let's move now from an arithmetic sequence, which is just a list, to what is called an arithmetic series. So the difference here in a series is that we are adding up the sequence. We add up every number in the sequence. There are infinite series, ones that go on forever, and there are finite series, ones that end. We are only looking at finite series in grade 10. We will look at infinite series in a couple of years to come. And now, depending on the information given, you can see here we have two equations. We have this one, and we have this one. So the caveat is for the first one, we need to know the last term in our list. If we don't know the last term in our list, we have to use this one. So, interesting where this one came from. Now, maybe an urban legend, but I'm pretty sure it's true. So the rumor goes that when Gauss was learning, he's a famous mathematician, when he was in math at school years and years and years ago, their teacher wanted to kill some time and said, I need you to add up all the numbers between 1 and 100. And he figured it would take him about 20 minutes. Well, Gauss, being a young genius, came up with the answer right away because he observed the pattern of 1, 2, 3, 4, all the way to 100. And he observed that 1 plus 100 is 101. That 2 plus 99 is 101. That 3 plus 98 is 101. So he observed this pattern that if you add the first number and the second and the last number together, you get the difference between the consecutive terms. And then the n divided by 2 means you just divide the list in half, because if you think about pairing up every number, your list drops from 100 numbers down to 50 numbers. And you can just get your answer by multiplying 50 times 101. So he finished instantly. That is where that equation comes from. And that's just a side story for you. Maybe this should be called the History Channel of Math with Herlaar. Who knows? But that's an extra bit for you. So let's move into an example. So add up the positive numbers from 1 to 50. Now this is a case where, guess what? We know our last number. It's 50. We know our first number. It's 1. So we can use the sum of the 50 numbers, n, is equal to 50 over 2 times a plus L, 1 plus 50. So we can just go, the sum of those 50 numbers is equal to 25 times 51. The sum of those 50 numbers is 1,275. So when you know the last number, it's pretty straightforward. What about if you don't? So here's one. We know there's 25 terms. It's given to us, but we don't know what the 25th term is. So we don't know L, but we do know D, because you can see in the sequence, it differs by 4. And we do know N. So N is 25, D is 4, T1 or A is 11. So do we need any more information than that? No, we just need to use the longer equation. We have Sn is equal to n over 2 times 2a plus n minus 1 times d. So we sub in the info we have. So n is 25. So the sum of 25 terms is equal to 25 over 2 times 2 times 11 plus 25 minus 1 is 24 times 4. And now it just becomes a bit of arithmetic. So the sum of the 25 terms is 25 divided by 2, so 12 and a half, 12.5, times 22 plus 24 times 4, which is 96. So the sum of 25 terms is equal to 12.5 times 22 plus 96, 118, which gives us the number 1,475. So we can sum up without knowing the last term as long as we know N, D, and A. So naturally, going to throw a curveball. Here's another one. Find the sum of this series. Now in this series, we know L. Great. We know A. Awesome. But we're missing a pretty important piece of information because in both of the equations, we need N. And I don't know N. But the good news is we can get N using our Tn equation. So we're going back to an arithmetic sequence for a second. Because if you think about the equation for the arithmetic sequence, we know the nth term, it's 100. We know A, we know D, we just have to solve for N again, right? This is our big one. So let's do that first. So the nth term, 100, is equal to the first term plus n minus 1 times my difference of 3. So I get 100 equals 7 plus 3 times n minus 1. Subtract 7 from both sides, and I am left with 93 equals 3 times n minus 1. Divide both sides by 3, and we get 31 equals n minus 1. And then add 1 to both sides, and n equals 32. So we've used the sequence equation to solve for n, and now we can use our sum equation because we know we have 32 terms, 32 over 2, and we know in this case a plus L. So we get sum of 32 terms is equal to 16 times 107. And now it's just a few keystrokes of your calculator and you get 1,712. So it's a bit of a puzzle because you got to solve for your missing information before you can solve the full thing, but that's what this is all about. So let's do one more. Similar scenario. We know A is 5. We can tell that D is 4, and we know that L is 137. But again, we just don't know N. So Tn equals A plus n minus 1 times D. The nth term, which is 137, is equal to 5 plus, I'm just going to rearrange the D and the n minus 1 right now, 4n minus 1. So now subtract 5 from both sides. 132 equals 4 times n minus 1. Divide both sides by 4, and you get 33 equals n minus 1. And then add 1 to both sides, and you get n equals 34. So now that we have that, we can use the sum of 34 terms is equal to 34 over 2 times 5 plus 137. which gives us the sum of 34 is equal to 17 times 142, which gives us 2,414. So this is all about acknowledging the equations we have given, finding the information we have, and moving forward from there. It can be intricate. It involves some puzzle pieces that we're trying to put together in the right spots at the right times, but it's all manageable. This is bonus this year, but definitely a good part of moving your reasoning and your logic forward. We'll see arithmetic and then something called the geometric series again in pre-calculus 12. So if you are curious, have a look here and give it a whirl. All right, remember that this ties into the bonus workbooks in grade 10, arithmetic sequence and series. Keep up the good work. We are going to move into section 3 here shortly. All right, take it easy.